All right, welcome back in. We've moved on to a new chapter, and this is lesson 5.2, which I am going to make a quick video of by popular demand. So what we're doing here is working with random variables, and the scenario here is about skee ball. You know, here's the skee ball machine, and you run up to it and roll the ball up, and if it goes in the center, you get a lot of points, and if it goes more in the outside rings, you get fewer points. Anyway, Mr. Wilcox and Mrs. Gallus spent a day playing skee ball and collected some data. Based on the data, who would you predict to win the match? All right, so we're going to analyze kind of how things went. And so we have two random variables. Random variable X is Mr. Wilcox's score for one ball. So for example, if you're looking at the probability that he'll roll a ball and get a 40, then it's going to be 14% of the time, 0.14. Or if he's just going to roll a 10, that's 0.4 or about 40%. And we have another random variable, y, for Mrs. Gallus's score for one ball, and it's kind of interpreted the same way. And it's set up from the point values of 10 to 50 the same way, but her probabilities are different. So let's do a little bit of a deep dive here. Okay, now the notes here are already written to spare you having to sit through me writing them. And so you're going to need to do some pausing if you are in fact writing along. So are X and Y, those two random variables, discrete or continuous? Well, they are discrete. You don't need a watch to measure this. It's just a counting kind of thing. There's a fixed set of possible values with gaps in between. So 10 to 20, 20 to 30, 30 to 40. You cannot score a 25. If you say, what is the probability of scoring a 25? It's a 0 because the machine isn't set up for that, okay? Verify that each probability distribution is valid. This goes back to 5.1. So we'll do the checks. All of these probabilities are between 0 and 1. All of these probabilities are also between 0 and 1. So check on that requirement. All right. So the next thing is to check each of these distributions separately to see if the probabilities therein all add up to 1. So 0.4, 0.6, 0.8, 0.86, and plus 0.14 is 1. So check on that. And then let's see, 0.5 plus 0.55 is 0.6, plus 1 is 0.7, and these two add up to 0.3. So all of this adds up to 1. So check, check, check. Those are valid probability distributions, and we're ready to do some analysis. So the first thing that they thought of was, well, what about the amount or the chance of them scoring on the two highest point values? So what is the probability that X is greater than or equal to 40, which would be the sum of these two? And that would be 0.2. And so they did the same thing for Mrs. Gallus for the random variable y, and this is going to be 0.1 plus 0.05 is 0.15. So it looks as though Mrs. Gallus gets to those higher scoring. This is a little bit less likely than it is for Mr. Wilcox. But I'm going to just kind of look at this and find the flaw in this reasoning, because for one thing, 0.15 and 0.20 are not that different. Okay, they are a little different. Yes, Mr. Wilcox, if it's based on this answer, he will be the winner. But, you know, it's only 5% difference. And furthermore, what's the thinking behind leaving the 10 score, the 20 score, and the 30 score off? Because if you include all 5 scores, maybe that would flip things in favor of Mrs. Gallus. So, okay, great. Mr. Wilcox won, but I'm skeptical. So for number 4, it says find the average of the X values, find the average of the Y values. Based on this answer, who will win? Right? All they're saying is take 10, 20, 30, 40, 50, which they both have, add them up and divide by 5. So they would both have a 30. So a tie, okay, maybe, but the way I look at it is that each of the scores don't have the same weight to them. For Mr. Wilcox, he's more weighted toward the low score here of 10, whereas Ms. Gallus is more weighted to the higher score of 30. And they're not putting in the weights. So think about it this way. If you were to try to get away with figuring out your report card by taking your homeworks, your quiz grades, and your test grades and add them all up and divide by however many there are, that would ignore the fact that tests count more and quizzes don't count as much, but they count more than homeworks. So you would have to do a weighted average to get something that would be meaningful, and this is not a weighted average. So this is a fine thing to think about, but I wouldn't declare a winner based on this by any means. All right, so using an applet in www.staplet.com, we're going to launch a probability applet and choose discrete probability distribution. We're going to enter Mr. Wilcox's data and begin analysis and do the same for Mrs. Gallus. Now you're seeing all the stuff that became of it, but let's just pretend this isn't here, and we'll just go. And what I ended up doing was I did a search on Staplet, and Staplet came right up. So then I'm just going to go to probability, and we want discrete random variables. Okay, so I'm going to start out with Mr. Wilcox, and I'm going to give him a title of, I'll get my keyboard here, Mr. Wilcox's, let's call it score for one ball. All right, and we just need to enter the value. His first value is a 10, and that had a probability, remember, 0.4, about 40%. And then the next value of the random variable was 20, and he was about 0.2. We need to add some more. And then 30 and 0.2 again. And now we're going to keep adding again. This will be 40, and he had 0.14. I'll just do 0.14, same thing. And then for 50, it was 0.06. 50 and 0.06. Okay, so all we have to do now is click Begin Analysis, and we're going to get a probability histogram, which is just the value of the points on the x-axis and the probabilities on the y-axis. So here is the graph of the distribution, and it asks you to draw it. We didn't draw it in class because it was a big time eater and nobody wants to sit there. It's bad enough listening to me in general, but just to have me draw a graph in front of you would probably be fatal. But anyway, here are your values for the random variable, and they are all on the x-axis. Here are the probabilities, and the biggest probability he had was 0.4. So the graph here only goes to 40%. Don't take a graph up to 100% if the highest value is a whole lot lower, because you're just going to have a whole lot of dead space up here. So this is kind of what it should look like. If you do it by hand, it won't look this good, but make sure it's readable. Now the other interesting thing that pops up is the mean, okay? There is a mean for a discrete random variable like this, and we will look at the formula for calculating it. There's also an average spread about that mean, or a standard deviation. And there is a formula that goes with that. I don't believe we're going to be responsible for it. And what I'm going to ask you now is just to hold on, and I'm going to put in for Miss Gallus. Oh, by the way, this distribution is skewed to the right, because if I were to pretend to make a slide over it, you would slide off to the right. All right, so I'll be right back. Okay, so we're back, and the only thing I didn't do was to change the title, but this will be for Mrs. Gallus. And look at her distribution. It's much more symmetric. Now, it's not perfect, but we're only looking for the most general thing that we can apply to it. All right, some people may argue, oh, it's got a little skew to the left, or to the right rather, but no. Let's just go with roughly symmetric. See, if I were to put a smooth curve and fit it, it would be pretty close fit. So his, Mr. Gallus's, was skewed to the right. Hers is symmetric. Here's her mean, which, by the way, if we think back on Mr. Wilcox, it was 22.6. Hers is 28.8. All right, that's substantially higher. The standard deviation is 8.035. Again, we'll look a little closer at those things. So let's kind of look back at the notes here. Let me pull that back up. And here are the results. Here's the graph we looked at for Wilcox. Here's the mean. Now you can calculate the mean easily without anything particularly like technology oriented. You just take the value of the random variable, in this case 10, multiply it by its probability, 0.4, and then do the same for all 5 of them, all right, the other 4, and add it to the first. Just add them all up. And this will give you a weighted average. This is exactly the way you figure out your report card grade. You find the average of your homeworks and the other grades. You find the average of the quizzes. You find the average of the test. You multiply the test average by however that weighting is, and do the same for the quiz, do the same for the homework, get 3 numbers, add them up, and you get your average. It's the same thing, all right? Over here, Mrs. Gallus, with her symmetric distribution, has a much higher mean. So the interpretation is, if Mrs. Gallus played many, many times, her average score would be 28.8. And the standard deviation, there's a lot more spread in Mr. Wilcox's distribution than Mrs. Gallus. And the way you would interpret that would be to say a randomly selected score from Mrs. Gallus typically will differ from the mean of 2.8 by 8.035 units or points. This is how you interpret these things. So the end result, based on the applet, who will win? Mrs. Gallus has a higher mean, so she's the winner. And I think this is totally defensible. Stand by, and I'm going to open up the next page and we'll go over it. All right, so we're on page 2 and we're going to start out with the learning targets. The first one is to make a histogram in order to display the probability distribution of whatever discrete random variable you're working on and describe its shape. So when you construct the histogram, remember the values of the random variable go on the horizontal axis, the x-axis, and then the probability goes on the vertical, and only go as high as the highest value that you've got, or perhaps maybe a tiny bit higher, but you don't go to 100%. Then you get what you get and describe its shape. Like for here, this is skewed left. So it's either skewed left or right, or it's symmetric, or it could be uniform. Uniform kind of looks like a rectangle. So that's what you have to do for your histogram. Learning target 2 is to calculate and interpret the mean. Now, it's also called expected value. So if they say, what is the expected value of blah, 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 that means find the mean. So find the mean or expected value of a discrete random variable. To do it by hand, you just take, okay, this little funny looking E looking thing is a summation symbol. It means add them up. What are you adding up? You're going to add up the product of the random variable, each value of the random variable times its probability. So down here, it would be 0 times 0.011 plus 1 times 0.032 plus 2 times 0.138, and so on until you get to the last one. And it's like figuring out your report card grade. It's the average of your homeworks plus the average of your quizzes plus the average of your test weighted, so that the tests are worth more and the quizzes are worth kind of less than that, and then the homework's average is worth less than that. Okay. All right, so when you interpret it, it's just, this is a script that you can follow. For many, let's just use Mrs. Gallus on the front. For many throws of the skee ball, the average points is, and I think hers was like 28.2, okay? So this is a good script. You just have to plug in whatever the context is. Now, learning target number 3 is to calculate and interpret the standard deviation of a discrete random variable. It says here, use the applet to calculate the standard deviation. I'm not sure, I don't think you can use the applet on a test or a quiz. So I'm going to show you how to do it on the TI Nspire. Okay. The interpretation of it though, once you find it, a randomly selected value will typically differ from the mean of whatever it happens to be by about whatever the value of the standard deviation is. So for Mrs. Gallus, a randomly selected throw of her skee ball will typically differ from the mean of 28.2 by about 8.038, I think was the standard deviation, something like that. So there, if you need to pause to copy that down, then you need to do that. Otherwise, we're going to move forward. So this application 5.2, how much do college grades vary? At this university, they post the grade distributions for its courses online. Students in the business statistics class in a recent semester received 45.7% A's, that's this. And those are 4 grade points. 36.2% B's, that is this. And that's 3 grade points. 13.8% C's, that's here, 2 grade points, and so on. With A equals 4, this is a random variable X of the grade points with this probability distribution. So you can already see that the histogram has been made. It's skewed left. We're going to do it on the Nspire. So here is the Nspire, which I don't have up at the moment, so I'm going to come back in a second. All right, so here we are at the Nspire, and to make the histogram, we need to move this highlighted cursor thing down, down, and then over, over, over until we get to a spreadsheet. So here's the spreadsheet. Get that highlighted, or not highlighted, but it gets big when you're on it. Go ahead and hit enter. Now what we need to do is we're going to use 2 columns and we need to name them up top. So scoot all the way up to here. And since they're calling this a random variable X, I'm going to call it X. You can call it what you want, but name it. Otherwise, it won't work. And then you need the numbers 0 through 4. Don't forget to check them to make sure they're right. Okay, mine look good. And once those are in, you're going to scoot over and highlight the second column. And I'm going to call it P for probability. Some people called it Y or something else. But here's where you need to put these numbers in carefully. 0.011, that looks good. And then the next one is 0.032. Okay, just always check to make sure they're right, because if you put garbage in, you get garbage out. So 0.138 and then 0.362. And finally, 0.457. Okay, everything is looking good. Just a quick note. Do you see how most of the probability is B's or A's, right? This is about 80% B's or A's. So they score pretty well in this department. So beyond that, how do we get to this histogram, right? We've got to go back to the home screen because we need to open a new page. So home screen. And we're right next to where we need to be, so go over 1 to the right, and these are stats graphs. So go ahead and hit enter. And then you got to follow along with me, because even though they did it while I was doing it in class, most of the kids forgot. So if you need to write down the steps, do it. So we need to get a variable here on the horizontal. Remember, that's going to be the values of your random variable, which is X. So the little balls just fall down. Now we need something on the vertical axis, but don't click it and put in Y. If you do that, the little balls will just make some kind of a pattern that sort of outlines what your histogram might look like. We don't want that. Okay, this is a special thing we have to do, so you may need to jot it down. You go to Menu, and then 2 for Plot Properties, and then we want this, Add Y Summary List. That's choice 9. So it's Menu 2, 9, and then you get a choice. Don't put X in there. We already have X here. Put P in there. Perfect little histogram, okay? You can use this to draw yours if you have to draw it. I'm trying to think if there's anything else. Oh, it's skewed to the left. Clearly skewed to the left. So this is what it looks like. Although there are missing values for the x-axis here. I don't know why. I think that's just a mistake. But it should look like that. And you can tell that most of the probability is being taken up by B's and A's. Okay, so there's that. Now, how do we calculate and interpret the mean of x? All right, and it says show work, so they don't want us to do it using technology. Remember how I taught you to do it. The mean is this value times its probability plus this value times its probability plus this value times its probability all the way to the end. So see it written out like this? So the average is 3.22. Now the central grade point value up here is 2. Since it's skewed and has most of the probability here, it's no surprise that the true mean will be way above the center of where the x values are. So how to interpret? If many students were selected, okay, that fits the script, their average grade point is 3.22. It's not their grade point average, their average grade point. There it is. Now you can do it on the calculator. I'm about to show it to you. Now the standard deviation is 0.879. Nice of them to give it to us. What if they didn't? All right, we're going to find it and then we're going to interpret it. It should be 0.879. So back to the calculator. Where did it go? Here it is. All right, so how to get those two numbers? Well, we need to go back to where we had the spreadsheet. So I'm going to move my cursor up here and just click on it. You can probably leave this highlighted rectangle here. I did have the kids move it to kind of a safe location, but really doesn't matter. What we want to do is do a 1 var stats. And I know you did this when you did histograms earlier in the year. It's just a little bit different. So menu and look. Choice 4 is statistics. Great, we'll choose it. And then choice 1 is stat calc. All right, stat calculations. You probably remember that, so I'm going to choose it. All right, and then 1 variable statistic. Now I know there are 2 columns, but the only really meaningful column is the first one with the values of the random variable. The other column is just weighting values, like to weight them. All right, so I'm going to choose this. Now when it says number of lists, yes, I know 2 columns, but this is the only one that matters, so we're going to leave it on 1. Just hit OK. All right, the X list, I'm going to take that off of there and then right arrow, and it's going to be X. Now, the next thing is really important. This is the big change. If I leave the frequency list on 1, it's going to count all those random variables with the same weight. I don't want that. So what I do want is to replace that 1 with that column P. And that's going to apply the weighting values to the random variable values, okay? And then you just tab down to OK. You can change this to C or D or whatever you want. Not to A or B. You don't want to wipe out what you typed in earlier, and just hit OK. All right, so now this comes up. The X bar is your mean. Remember 3.22? Actually, it's a Greek letter here. It should be like a mu or something, but we'll just go with however they labeled it. Now the weird thing is that if you scroll down to the standard deviation, it says undefined. That's because the calculator knows you're not giving it data. It knows you're giving it a random variable. Data standard deviations vary from sample to sample. However, this is a fixed standard deviation. So we're going to go down 1 more and see how it has that little squiggly symbol. It's a sigma. and that means that it's going to be the true value. There is no sampling error or anything, and so there it is, 0.879. It's exactly what we had. Okay, so that's it. Let's go ahead and read the rest of it, and then we can close this out. So the interpretation: a randomly selected student has a grade point that typically differs from the mean of 3.22 by about 0.879. So both those interpretations match up actually pretty well to the learning targets. There you have it. Thanks for watching. I'll see you next time.